Hi students. Okay, today we are learning the topic is Taylor series method. So in this method to finding the approximation solution of first order ordinary differential equation with the initial conditions. So that is the initial condition means given to finding the next approximation value. Okay na? So only to solve, that is finding the numerical solutions to the given first order differential equations. So without using the initial condition we cannot finding the remaining values only. Compulsory using the initial condition, now finding the next values, next approximation values. Okay na? So that is the first method, Taylor series method. Okay, in this method how to solve the given differential equation with the initial condition. Okay na? See the first procedure here. So let dy by dx is equal to f of x comma y of x naught is equal to y naught. So this is a given first order differential equation only with the initial condition y of x naught is equal to y naught. So next we have assumption x naught comma x1 comma x2 comma up to so on xn are equally spaced points with the step length h and the same step length. That is a difference between x1 x0 x2 x1 up to so on, all difference must be same. So now to find the values of y at x1 comma x2 comma up to so on xn, that is the solving only. So you are given initial condition y naught at x naught. Now next values we have to finding y of x1 y of x2 up to so on, that is the finding. So in this method then how to finding here, see that. So that is equal to, your formula is given by using Taylor series method. Y of xn plus 1 is equal to, that is yn plus 1, both are same only. That is equal to y of xn plus h into y dash xn plus h square by 2 factorial y double dash of xn plus h cube by 3 factorial y triple dash of xn plus up to so on, where n is equal to 0, 1, 2 up to so on. And n is equal to 0 substituting, we getting the y1 value, that is y of x1. N is equal 1 substituting, we getting y2, that is y of x2. And using to finding the y1 using y0, to finding the y2 using y1, that is to finding y3 using y2, that is using the previous values we have to finding the next values. And so this is method is called the Taylor series method, or in other terms another formula is, both are same and both are same formula. Y of xn plus 1 is equal to yn plus 1 is equal to, y of xn means yn, so plus h into y dash n plus h square by 2 factorial y double dash n plus up to so on, where n is equal to 0, 1, 2 up to so on. Okay, now this is called the Taylor series method. So see that note, y of xn plus 1 is equal to yn plus 1 is equal to y of xn plus h into y dash of xn plus up to so on h power p by p factorial pth derivative of y at xn, and it is only finite expansion only. The Taylor series expands up to pth order only. This is called pth order Taylor series method, and we have to finding any order. So in the above formula up to infinity, so we have to finding any first order, second order, third order up to so on, any order. P is any positive number. Substituting it, we have to finding the any order of the Taylor series method. Okay na? So that is equal to next one, second note, y of x is equal to y of x naught plus x minus x naught into y dash x naught plus x minus x naught whole square by 2 factorial into y double dash of x naught plus up to so on is the solution of given differential equation at x naught only. So this is the only direct solution only, y of x. And to solve the given differential equation using the initial condition, directly finding the solution only in terms of x. So directly substituting here x naught value and x minus x naught, right, x naught value, next y dash of x naught and a differentiating value. So next second differentiation, third differentiation, in that all values substituting the initial value. So we getting the solution of the given differential equation of first order in this Taylor series method. Okay na? Okay, now see that one example problem here. Yeah, for the differential equation, dy by dx is equal to minus xy, comma y of 0 is equal to 1. Find y of 0.1, y of 0.2 by using second order Taylor series method. So second order means the Taylor series method expand up to only second order, but not taking infinite terms. Okay, now only up to second order we have to choosing. So we are observing here, we have to finding y of 0.1, y of 0.2 and so what is the initial condition is 0 kada. Y of 0 is equal to 1 and x naught is equal to 0, y naught is equal to 1. And the next approximation ఏంటి ఇక్కడ 0.1 కదా 0.2 అంటే స్టెప్ లెంత్ ఏమవుతుంది స్టెప్ లెంత్ is 0 0.1 0.2 కదా and the step length is 0.1 అంటే చూడండి యాడింగ్ 0.1 to all values x0 0.1 next adding 0.1 0.2 that is a way how to finding two values here y1 y2 that is y of x1 y of x2 anamata. So that is equal to here. So given differential equation, so that is dy by dx means y dash here, y dash is equal to minus xy. So here x naught is equal to 0, y naught is equal to 1. So to finding y of 0.1, y of 0.2. So that is y of 0.1 is equal to y1 at x1 is equal to 0.1. y of 0.2 is equal to y2. So that is x1 is equal to 0.1, x2 is equal to 0.2. So a step length. So x while sent ikkada 0, 0.1, 0.2 kada. Step length same 0.1. So second order Taylor series method is given by, so this is expansions kada. Taylor series expansion up to choosing second order and that is h square by 2 factorial. So ikkada n is equal to 0, 1, 2, 3 we have to finding n is equal to 0 substitute first value y1, n is equal to 1 substituting we getting the y2. Only n is equal to 0 and 1 substituting because only two values finding here. Okay now, so this is the formula for Taylor series. Okay, first to finding y of 0.1. okay now, so that is equal to find y of 0.1 in the above formula substituting n is equal to 0, that is equal to y of x1 is equal to y1 is equal to y naught plus h into y dash naught plus h squared by 2 factorial y double dash naught. Okay now, so here x1 is equal to substituting 0.1. So y of 0.1 is equal to same y1 is equal to y naught plus h into y naught dash plus h squared by 2 factorial y double dash naught. Okay now, so next finding the values y naught is given, next finding y naught dash here అంటే already given dy by dx, next to y naught double dash. Now finding the second order derivative. So y dash is equal to given, so in this equation substituting x plus to x naught, y plus to y naught. So y naught dash is equal to minus x naught y naught, x naught value 0, y naught value 1 already given. So y naught dash is equal to 0. Next one y double dash. So this is the second term differentiation andi, y dash to second term derivative y double dash. Next minus x into y derivative kada అంటే uv method, u into v అంటే minus x into y కి derivative y dash minus y into x కి derivative 1. So this is the second derivative. So in this one substituting x plus lo x naught, y plus lo y naught. So that is y naught double dash is equal to minus x naught into y naught dash minus y naught. So minus x naught value 0, y naught dash value already finding 0 minus y naught value 1. So that is equal to y naught double dash is equal to minus 1. Substituting in equation 1. So from equation 1 y of 0.1 is equal to y1 plus, so y naught 1 plus h step length 0.1 into y naught dash 0. So h square by 2 factorial ante 0.1 whole square by 2 into minus 1. Okay, now simplification is 1 plus 0 minus 0.005 that is equal to 0.995. This is the first value y of 0.1 that is y1. చూడండి y of 0.1 y1 is equal to 0.995. okay na, ఇది ఫస్ట్ వాల్యూ. నెక్స్ట్ ఫైండింగ్ సిమిలర్లీ we have to finding y of 0.2. So y of 0.2 means in the Taylor series formula substituting n is equal to 1. Okay, na? So that is equal to find y of 0.2. That is equal substituting n is equal to 1. So y of x2 is equal to y2 is equal to y1 plus h into y1 dash plus h square by 2 factorial y1 double. Okay, na? And we have to finding y2 kada. And using the previous value y1 value using. For finding y1 using y0 x0. Okay, using for finding y2 means using the x1 y1. Okay, na? So that is equal to here. Put x2 is equal to 0.2. So that is equal to y of 0.2 is equal to y2 is equal to y1 plus h into y1 dash plus h square by 2 factorial y1 double dash. So finding here first y dash is equal to given minus xy. In this substituting x plus lo x1 y plus lo y1. y1 dash is equal to minus x1 y1 is equal to x1 value 0.1 y1 value already finding 0.995 that is equal to minus 0.0995. So next one y double dash. The second derivative find out chain. Y double dash is equal to minus x into y dash minus y. So substituting x plus lo x1 y plus lo y1. So y1 double dash is equal to minus x1 into y1 dash minus y1. x1 value substituting 0.1 y1 dash here 0.0. Okay, that is substituting minus 0.1 into minus 0.0995 minus 0.995. Simplification is minus 0.98505. Okay, now this is a both values substituting in equation 2. So that is equal to from equation 2 y of 0.2 is equal to y2 substituting y1 value 0.995 plus h is equal to step 10 0.1 y1 dash value minus 0.00995 plus 0.1 whole square into this value minus 0.98505. Simplification is, so this is a required value y2 value. Y of 0.2 is equal to y2 is equal to 0.9801247.5. So this is a Taylor series method. Okay. So see the next example one. So find y of 1.1 from dy by dx is equal to 2x minus y. Y of 1 is equal to 3 and compare with the exact solution. And first finding the numerical solutions by using the Taylor series method. Next exact solution finding and so manam general method find out cheyali the linear equation or exact non-exact using the variable subrable method. So using that method we have to finding the exact solution. Next to comparing both solutions. Okay, na? First finding the numerical solution. So there is a given equation y dash is equal to x minus y. So initial condition y of 1 is equal to 3 and x0 is equal to 1, y0 is equal to 3. So next second derivative y double dash is equal to, so 2x here, 2x derivative 2, y derivative y dash. So next third derivative y triple dash is equal to 2 constant 0 minus y dash derivative y double dash. So next fourth derivative y power fourth derivative is equal to minus y triple dash. So we have to finding up to we can infinity kada, but there is no particular here Taylor series. We can finding up to second, third, 4 is enough. 4 enough is enough only. Okay, now using the Taylor series method. So next in this one substituting initial value. Okay, na y dash naught is equal to 2x naught y minus y naught. That is equal to y naught dash is equal to 2 into 1. Y naught is equal to 3. That is equal to minus 1. Next to y naught double dash is equal to 2 minus y naught dash. That is equal to y naught double dash is equal to 2 minus of minus 1, 3. Next y triple dash is equal to minus y naught double dash is equal to y naught triple dash is equal to minus 3. So fourth derivative y naught is equal to minus y naught triple dash is equal to minus of minus 3 is equal to 3 up to so on. These all values substituting initial value and okay na. So therefore to finding y of 1.1 and this is the first value y1, that is y of x1, where x1 is equal to 1.1 and step length 0.1, because initial value x0 is equal to 1 kada. Next you have to finding the 1.1 next value kada, that is step length is 0.1. So Taylor series method using, so this is a Taylor series method formula and y of xn plus 1 is equal to yn plus 1 is equal to this formula. Okay na, in this formula substituting all values, put n is equal to 0 here. Okay na, first to finding put to n is equal to 0 means we have to finding the first value y1. Here y1 is equal to y of 1.1. So that is equal to y of x1 is equal to y1. Okay na, substituting that value. Next to substituting x1 is equal to here 1.1 again. So y of 1.1 is equal to y1. All values substituting y naught value, y naught dash, y naught double dash, y naught triple dash up to so on, and h is also step length substituting. Okay na, simplification is, so this is a value, this is a numerical value, y of 1.1 is equal to 2.9145125. This is a numerical value. Now finding the exact value. Now finding exact solution. So given equation dy by dx is equal to 2x minus y. Initial condition y of 1 is equal to 3. So this method, this problem is can be solved by linear differential equation kada, which form is dy by dx plus py is equal to q. So to finding the solution, we have to getting the solution, that is the solving by linear differential equation form, that is indicating factor finding e power integration of p dx. Next solution y into indicating factor is equal to integration of q into indicating factor into dx plus c. Using that formula we have to finding the solution. Okay now, this is the exact solution only. So next finding the c while finding the particular value kada. So c is a finding by using the initial condition, and x is equal 1 substituting y is equal 3 in this one. So that is equal to find the constant c, y of 1, x is equal 1, x is equal 1 is equal 3. So 2 minus 2 plus c into e power minus 1. So therefore c is equal to 3 into e power 1. E power 1 value substituting, and 3 into e power 1 is equal to value 8.1548. This is the c value. So substituting in the above solution, so y of x is equal to x minus 2 plus 8.1548 into e power minus x. This is the exact solution. So in the solution now finding the value is y of 1.1 kada, and x place low 1.1 substitute. So that is equal, put x is equal 1.1, that is y of 1.1 is equal to 2 into 1.1 minus 2 in plus 8.1548 into e power minus 1.1. The simplification is 2.9144971. This is the exact value by using the exact solution. Okay na, that is a numerical value 2.9145125. This is a numerical value, this is exact value. So both are nearly same. So perfect same rakapayina nearly same ostundandi. So that is the difference between numerical value and exact value. This is a Taylor series method. Okay. Okay, thank you. For more videos, please do subscribe my channel, like and share it. Thank you.